In this video, we will discuss how to convert regular language into context-free grammar. In previous video, we have seen how to convert finite automata into CFG. Now we'll see how to convert language into grammar. So L is equal to A. So this language contains only one string, that is A. So the straightforward solution for this would be a single production, that is S gives A. So if we start with the initial state S, it can only produce one symbol A. There is no recursive definition. So it is equivalent to given language. And grammar we can write down in this way: G is equal to VTPS, where V is equal to set of all non-terminals, that is capital S. T is set of all the terminals, we have only one, that is A. P is set of all the productions, and S is the initial production. Let L is equal to AB. So this language produced two strings A and B. So again, this is also very trivial example. By adding these two productions, we can generate both the symbols. And for G, we can define in this way, where only difference would be in T and S. T contains now two symbols, A and B. And the production S tends to A and S tends to B. This language contains four strings AA, AB, BA, BB. So that is also quite simple. We can write down simply four productions. S gives AA, S gives AB, S gives BA, S gives BB. So whenever length of L is finite, we can always write a context-free grammar for that. And that many number of productions you can add, but that is not appropriate way. We can simplify that with the help of regular expression as well. The another way of doing this is we can write regular expression for the given language. So the RE for this would be A plus B concatenated with A plus B. So A plus B we will represent as a capital A. So this representation of R would be A into A. And now we can start with S gives AA, and A we know that it is either A or B. From that pair we can select either A or B. So we can have production like this: A implies A or B. So using these two productions, we can produce all four strings: AA, AB, BA, and BB. And this is the grammatic representation of that. Let us take some more complex language. L is equal to 0 or more A's, that is epsilon, 1A, 2A, 3A up to infinite A. And regular expression for that would be A star. That means initial state is the final state. When we draw the FA, initial would be the final. Epsilon is a part of language. So there must be a production S implies epsilon. And we want to generate 1A, 2A, 3A, 4A, infinite A. So there should be some recursive definition to generate A. So what we are doing is we are simply writing S gives AS. So depending upon number of A's, we can keep iterating this S. And when we want to terminate, we will replace that S by epsilon. Language contains one or more A's. So that will be single A, double A, 3A, etc. And the regular expression for that would be A plus. So here the grammar would be S gives AS or A. So epsilon is not present here in the language. So we should not add epsilon here. So either single A or multiple A we can generate using AS, recursive definition. So for single A we will use the second production. For multiple A's we will use the first one, and to terminate we will replace it with the single A. And this is the just a grammatical representation. L is equal to any number of A's and B's. So that could be 0A, 0B, 1A, 1B, 2A, 1A, 1B, any combination of A and B. And regular expression for that would be A plus B whole star. In any order we can read A and B. It's not like we should read first A and then B only. It is not A power n, B power m. It is A plus B whole star. And the productions for that would be defined by S gives AS. We know that using this production we can generate A power n, any number of time or any number of A's we can generate. Using S gives BS we can generate any number of B. But to terminate we have to use something, right? So we'll write S implies epsilon. So epsilon can also be generated, A can be generated, B can be generated, AB, double A, BA, double B, any combination of A and B we can generate. So this is very important production to remember. Very often we are going to use A plus B whole star throughout the discussion. So make sure that you understand it properly. Using S gives AS, we can generate any number of A. Using S gives BS, we can generate any number of B. And to terminate, we will use the third production. Language contains all the strings which are having at least two A's. So before first A, we can read any string. Between 2A, we can read any string. And after second A, we can read any string. But 2A must be there, at least 2A. So this regular expression will generate all the strings which is having at least 2A. So let us rewrite in other format. Now A plus B whole star is a variable. Okay. It can generate any string over A plus B. Whereas small a after that is a constant. You cannot produce any other string from the terminal. So we are writing it as it is. Only A plus B star we are replacing by capital A because that is a generating part which will generate multiple strings. So we need some recursive definition for that. So this regular expression we can write as capital S implies capital A, small a, capital A, small a, capital A. And capital A we have to use to produce A plus B whole star. And on previous slide, we have already seen how to produce A plus B whole star, right? So A implies AA or BA or epsilon. So using this recursive definition, we can generate any string over A and B alphabet. Language contains at most two A's. At most two A's means you can have a 0A, 1A or 2A, but not more than that. So initially we can read any number of B. Then there is a provision to choose either A or null symbol, right? So we can read 1A or 0A. Then again we can read any number of B. Again we are allowed to read 1 or 0A and then B star. Right? So we can choose 0A, 1A or 2A from those parentheses. And before, between and after those A's, we can read any number of B's. So here we have a repeated units. So we will simply consider S is equal to A, B, A, B, A. Where A we will use to generate B star and B we will use to generate A plus epsilon. So B star we can generate using the production A implies BA or the epsilon, and A plus epsilon we can generate using B implies A oblique epsilon. Language contains all the strings in which there is at least one occurrence of 000. So one occurrence is compulsory. Before that we can read anything, after that we can read anything. So the regular expression for that would be R is equal to 0 plus 1 whole star, 000, 0 plus 1 whole star. And grammar for that we can write down in this way. S implies capital A, 000, capital A. 000 is a terminal. They cannot produce anything, so we don't need to take any variable for that or capital B for that. Fine, only 0 plus 1 star is the generating part. So for that we need recursive definition, so we are taking variable for that. And you already know how to produce 0 plus 1 whole star, right? Using A, so that will be 0A or 1A or epsilon. Strings starting with A and ending with B. So regular expression would be A plus B whole star, B. So first letter is A, last letter is B. In between we can read anything. Anything that means A plus B whole star. Now again that's pretty straightforward. S gives small a, capital A, small b, because first and last symbols are terminal. They are not generating, so there is no need of writing capital letters for that. Only we have to generate A plus B whole star using the middle capital A. And that we know it's small a, small ba and epsilon. Language contains strings starting with and ending in different symbols. So if our string is starting with A, it should end with B. If it is starting with B, it should end with A. In between these A and B or B and A, we can read any combination of A and B. A capital A B oblique B capital A small a. Because small a and small b are terminal symbols in both the half of the regular expression. Only generating part is A plus B whole star. And it is common in both. So there is no need to take capital A for the first half and capital B for the second half. The same capital A will work for that. And using capital A, we will produce A plus B whole star, which is given by AA or BA or epsilon. Language contains all the strings of even length over alphabet A comma B. So it could contain epsilon, or it could contain double A, AB, BA, double B. Then it would contain strings of length 4. So we have to take the repetitions of 2 alphabet at a time. So we have A plus B whole star. So it will ensure there would be 0 occurrence of either of them, or there would be 2 occurrence, or that would be 4 occurrence. Fine. So any length, any string of even length would be produced by this regular expression. And this is now pretty straightforward that S gives, we are assuming A for this A plus B. And we have a 2 units of A plus B. So we will write 2A and it should be repeated. So we are writing here capital S. So next time there would be 4A, next time there would be 6A, 8A and goes on. And when we want to terminate, we will replace that capital S by epsilon. And using A, we have to produce either A or B. So that simply A implies A or B. So we will get strings of even length. Language contains string having ABA as a substring. So before ABA, we can read any combination, that is A plus B whole star. After also, we can read any combination, that is A plus B whole star. So production for that would be capital S gives capital A, small ABA, capital A. The small ABA again is a terminal, it's a constant, so we will not write any capital letter for that. Using capital A, we are writing the definition for A plus B whole star, that is AA, BA or epsilon. Strings beginning or ending with double BA. So the first half of RE is showing all the strings which are beginning with double BA. So first 3 letter must be double BA. After that, we can read any combination of A and B, or initially we can read any combination of A and B, and at last we can read double BA. The production for that would be S gives triple B capital A or capital A triple BA. Because this triple BA is a constant, it is not generating, so we want to replace it by capital letter. Only generating part we will replace by the capital letters. And using that capital letter A, we will produce A plus B whole star. Give context-free grammar for balanced parenthesis. So either there could be a square bracket or curly bracket or the round bracket. The thing is that whatever bracket we are opening last, it should be closed first. Nestedness is allowed within square bracket. Within square brackets, you can open curly bracket. Within curly bracket, you can open round brackets, or anything is possible. Any order you can do that. But whenever you are opening something, you have to close it, and that is also in corresponding order. So for that, context-free grammar would be S gives SS. That is for the repetition. You can have any combination, any length of string, and then you can have a S within square bracket, S within curly bracket, S within parenthesis, or you can terminate with the epsilon. So this will ensure that you will always have balanced parenthesis strings. Give context-free grammar for set of even length strings in A, B, C, D star with 2 identical middle symbols. So what it says, our input alphabet is now A, B, C, D. We have to generate all the strings of even length, and middle 2 symbols should be same. So S is defined for this language as shown. S gives ASA, ASB, ASC, ASD. Because our string can start with A, end with A, B, C, D. Same way, our string can start with B, and it can end with A, B, C, D. Same is true for C, same is true for D. So recursively, we can generate any random string, but the middle 2 characters must be same. So to stop, we will use the last line, that is S gives either double A or double B, double C or double D. So when we are using any production in random order, it will ensure that 2 characters are produced at a time. Because it is ASA or ASB format, always it will produce two terminals at a time when we do the replacement. And order can also be any random. And whenever we want to terminate, we must have to use the last row, which will ensure that middle 2 symbols are always identical. Union rule for grammar. L1 is equal to A power n greater than 0. So for that, we can define context-free grammar like this. S1 implies A S1 or A because n is greater than 0. If it would be n greater than or equal to 0, then we can replace the A by epsilon. And L2 is equal to B power n, where n is greater than 0. So production for that, we can write S2 gives B S2 or B. So we can have a B power n, we can generate using this 2. We can generate all the strings by taking the union of these 2 grammar in following way. We just have to do, or we have to create one more production S, which will select either string for S1 or from the S2. And we already have productions for S1 and S2. So when we use this capital S production, it will form the union of all the strings from L1 and L2. So that is very simple rule. We just have to create one additional start symbol, and that should point to all the possible productions in the grammar. Concatenation rule for the grammar. So it's pretty identical. It will generate all the strings concatenated from L1 and L2. So here, instead of a pipeline, now we will concate S1 with S2 using dot. So S gives S1 dot S2, that production we have to use. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.